So here we go. So we're going to be going over the density practice problems. Now, the number one thing to know about density is that it is a conversion factor. I don't use that d equals m over v. Don't try to work that in. See if you can use it just as a piece of your bigger conversion, because that is going to save you a ton of time. That's what we had really I pushed on way back in chapter 1, but it's been forever since chapter 1. So if we look at this first problem, how many atoms are in that much sample of lead? So first off, in the end, we are going to be looking for atoms here. So that's what we're trying to go for. And we've got two different things. We've got the milliliters over here, and we've got the density. Now, the big thing to know is that you may be tempted to start with density, but that is a bad idea. In most cases, you will not start with density. Density in itself is just going to be a conversion factor, meaning that 11.36 grams is equal to 1 milliliter. So that's like one of the biggest things here is, in this case, 11.36 grams of lead will be equal to 1 milliliter of lead. So that's kind of like the huge takeaway about this. So we start with the other thing, in which case we've got 2.40 milliliters of lead. Okay, so we'll do our times line like we've done before, and we're going to find that we're going to need to do two conversions for this one. Okay. Once you do this enough, you will start to see why that happens. But the reason is we're not going to get just from density what we need. So we're going to have to do something else to it. And that's where this conversion comes into play. Because this idea that we have here of 11.36 grams of lead is 1 milliliter of lead, that's what we're going to be using right away. So we take our milliliters of lead and we bring that down, lead there, and we have 11.36 above. I mean, I should just copy and paste it. It probably would have been easier. That's okay. All right, now we're in grams of lead. Milliliters are going to cancel, and we will be left with something much more useful. So milliliters cancel. You're left with grams. So we're going to put grams at the bottom. Now this thing wants it to be in atoms. So in that case, it's not too bad. We can just go from grams to atoms using a simple mole conversion like we've done before. I'm not even going to try anymore. So when we look at lead, we can look that up on the periodic table. It's 207.2 grams of lead is going to be equal to our 6.02 times 10 to the 23rd atoms. So that's our general setup. In doing this, you should get the answer that's posted there of 7.92 times 10 to the 22nd.
Great. Thank you so much.
No problem. Now, for the other one, what you're dealing with is the same general scheme, is that density is just a conversion factor. It's just something that we can take from one piece to another. So that lets you know what you can start with, and then you can kind of go from there. So do you mind if I do this one?
No, I don't mind at all. That'd be great.
Okay, so we're going to start with the non-density things. So that would be moles of aluminum. Okay, now, in this case, we just want space. So here, we're still going to need two steps because we've got moles isn't going to give us directly into our density, but it will get us to something more useful, grams. So on the bottom, All right, on the bottom, we've got our normal thing. Now there is 26.98 grams of aluminum in a mole. I put that in the wrong place. 1 mole will become the 26.98. And both of these should be listed as aluminum. Alright, now this brings us to using our density, which we had over here. We get that from the problem. The problem says the density of aluminum is 2.67 grams per milliliter. Since we have grams, that means we can put that on the bottom of 2.67 grams of aluminum and make that equal to 1 milliliter of aluminum. Milliliter is volume, volume is space, and there we go. So the first example question, we started with converting. We started with our density right away, and then we converted to mole. The second started with mole, and then we converted to density.
Okay, great.
Whatever the problem asks, that's what you do.